So if I look here at my little line, AB, oh I'm sorry, we're going to pull this up. Or we just call it AB. So instead of saying just the length of AB, you can just say AB. And I know that you're talking about the length of it, how long it is. Okay? If we look over here to our little picture, we have A, our start point, B, our end point. All you gotta do is count how many things they have. So 1, 2, 3, 4. So how long is AB? 4. Okay. If we have two things that are the same, so if AB equals CD, so if they're the same length, then we say that segments are congruent, they're equal. Okay, how we write congruent is this little equal sign with a squiggly on top. Okay, so if they're the same length, we write that as AB is congruent to CD. So again, if I look over here, how long is AB? 4.
Yeah.
How long is CD?
4.
4. So are these two segments congruent? Yep, they're the same length, so they have to be congruent. So AB is congruent to CD. Okay. Congruent is, right now we use it as a way to say equal. Later on, it doesn't necessarily mean equal. But it does have an equal sign squiggly, so if you use the word equal, that's fine with me. Okay, good so far? Alright, segment addition. All it means is that you take segments, and addition means add them. Okay? I like to think of it as you are taking a line, and it tells you B is between A and C. It doesn't actually have to be B, but any point that's in between your other 2 points. What happens is our 2 small segments add up to be our big segment. Okay? So all we're going to say is that AB, my small one, plus BC, another small part, is equal to the whole thing AC. So I just kind of think of it as like a chunk plus a chunk equals the whole. Or a part plus a part equals the whole. Okay? So if I told you that AB was 3 and BC was 7, how big is AC the whole thing? 10. Yeah. That's all this is saying. Is that if I add the 2 small parts, it has to equal up to the big part. Okay. Questions there? So, if I have PQ is 9, so this little chunk here is 9, and QR is 28, so this chunk is 28, how can I find PR, my whole line? What do I do? Add them, yeah. 9 plus 28, you guys got calculators?
Yeah.
Or mental math? Who's got it?
37.
37. So my whole thing, PR, is 37. If I know QR is 17, so this little chunk is 17, and PR, the whole thing, is 21, am I going to add these two? No. What am I going to do? Subtract them. Find my little chunk. I'm going to take 21 minus 17 and get
4.
or awesome. Okay. Questions there? All these mean we're we're just throwing in x's. It's the exact same stuff we were doing here. We just got x's. Okay, so just taking it a little bit further. So, if I know EG is 71, EG is the whole thing, that's 71. And I have 8x minus 17 is EF, and FG is 5x minus 3. What am I going to do with these two? Yeah, plus, add them. And what should it equal? Yeah, the whole thing, 71. Awesome. So we're just going to take this part, which is 8x minus 17, add this chunk, 5x minus 3, and set it equal to my whole line, which is 71. Questions on where I got any of that info?
Just supposed to find the value of x.
Yeah, now we just gotta solve it.
Oh, okay.
Okay, so solving, let's combine x's first. 8x plus 5x gives me 13x. Minus 17 minus 3 gives me
Negative 20.
negative 20. And still equal to 71. There's nothing to do with 71. Okay, from there, how do I solve? Add 20. So add 20 here, add 20 here. So 13x equals 91. Last thing to do,
Divide by 13.
divide by 13, good. And x equals, who's got that? 7. And that's what we're supposed to do is find the value of x. So we're done. Questions there? Okay, move another one. I know TU is 9x plus 2. I know UV is 5. And TV, my whole line, is 14x minus 8. What should I do? You can tell me in colors if you want. Add what colors together? Green and blue? What do you think? Add green and red. Subtract blue. Well, so I have this chunk, right? And then my red chunk. If I add those two together, does it equal anything? Yeah, the whole blue thing, my whole line. This whole blue chunk. It's the same length. Okay? So let's take our green chunk, our 9x plus 2. Want me to write that in green? Write that in green. Or is that confusing? No. Take our green chunk, 9x plus 2, and add our red chunk, which is 5. And that has to equal our whole line, our blue chunk, 14x minus 8. Okay, our two smaller parts have to equal the big part. Okay, so let's combine like terms. I have no other x's on this half, so just 9x plus 2 and 5 give me
7.
7. And then can't do anything. No simplifying on the other side. I like to deal with x's first. What should I do with my x's?
I'm on one side.
Put them on one side. Which one am I going to move?
14.
Move the 14? Subtract it, add it, what?
Subtract.
Subtract it, so if I subtract 14x from 9x, I
No,
get
subtract 9.
subtract 9x, there we go. subtract my 9x. No x's over here. I got 7 equals how much x?
5.
5x minus 8. Now what?
Plus 8.
Add 8. Good. Plus 8. Plus 8. 7 and 8.
15.
So 15 equals 5x. Then what?
5x.
Divide by 5. Good. X equals 3. Okay, here's the super tricky part. Up here it says find TU. So I need X, but my answer I want to be TU. TU is my green part. It says it's 9x plus 2. So if I know X is 3, how can I help find 9x plus 2?
Multiply the 9 with 3.
Yeah, just plug in my 3. So we're going to plug in 9 times 3 plus 2. Because this is what we're looking for. 9 times 3 is 27 plus 2? 29. So TU equals 29. Okay. Questions. Okay, let's do another one. I know JK is 27. I know KL is 3x minus 1. And JL, my big line, is 5x plus 2. I want to find JL, which is my big blue line. What should I do? How should I set it up? Add the red and green and do what to it? Set it equal, subtract it, multiply it. So add the red and green. So we got 27 plus our 3x minus 1 equals
5x plus 2.
good. 5x plus 2. If you ever start like solving something, like doing what we were doing, and you don't have an equal sign, that should be like a huge red flag. Okay, always look for equal sign. Stuff has to be equal before you can start like adding and subtracting stuff. Okay. All right, perfect. So, can I combine anything on the left? Yeah. What can I do? Subtract 1 from 27. What do I get? So I got 3x plus 26 equals 5x plus 2. I like my x's out front, that's why I wrote 3x first. Then what should I do?
Subtract 3x.
Subtract 3x, good. If I subtract 3x, what do I get? How much x?
2x.
2x. Then what?
Subtract 2.
Subtract 2, what do I get?
24.
2x is 24. Then
Divide by 2.
divide by 2 and x is 12. That's all fine and dandy. Do I really care what x is? Is that am I done? No, what do I need to do? I need to find the blue stuff. How can I find the blue stuff?
Plug in the 12.
Plug 12 into my x, right? 5x plus 2, I know that's my blue stuff, so let's just plug our 12 into here. So I got 5 times 12 plus 2. Who's got 5 times 12 plus 2? 62, so JL is 62. Okay, one more of this kind. I know CD is x plus 3. I know DE is 8x minus 9. And my whole line CE is 7x plus 4. I only need x. Thank goodness. Who can set up? Go for it.
X plus 3 plus 8 x minus 9 equals 7x plus 4.
You guys agree?
Yeah.
Yeah. Okay, what can I simplify on the left? X is how much x do I got?
9.
9x. Anything else I can simplify?
Negative 9 and 3.
Negative 9 and 3 makes
Negative 6.
negative 6. Good. Can I do anything on the right?
No.
No, just rewrite it. Now what? Subtract 7x and I get how much x? 2x, so I got 2x minus 6 equals 4. Then what?
Add 6.
Add 6, which gives me 10. And then I bet you can get 5. All I needed is x, so we're good to go. Okay. How do we feel about our segment addition postulate, super fancy name? Good. You feel like super geniuses? No, I feel like a super genius. What do you mean? I let you go. Well, are we good on these, or you want to do this one? We're good. Alright. We're also going to talk about midpoints today. Midpoint. What do you think it means?
Intersecting point.
Intersecting a point.
Point in the middle.
In the middle, yeah. Middle is the huge part. It is a point in the middle, and sometimes we intersect it. Okay? The midpoint of a segment is a point that divides a segment into two congruent segments. That is a super fancy way to say point in the middle. The important part is that it is exactly in the middle. Okay? So if it's exactly in the middle, does everybody know what these two dash things mean?
The midpoint's equal.
Yeah, they're equal. It's a midpoint. Okay? So what that tells me is that however long AB is, BC has to be the same length. So if this is 5, this has to be 5. Okay, that's what a midpoint does. It splits it exactly in half. Okay. A line where a segment that intersects a segment at its midpoint is said to bisect this segment, and is called the segment bisector. So here's kind of the weird thing about geometry. We have two words for basically the same thing. Okay? Midpoint means it's exactly in the middle. It has equal parts on either side. Bisect means it cuts it in half, so that we have equal stuff on each side. The only difference is midpoint is a point, and a bisector is something that goes through, so like a line. Okay, so let's just put bisector cuts in half. Whether the problem tells you it's a midpoint or a bisector, you do the exact same thing. You have equal parts. So you're just going to set things equal. Okay? So two different words, you're gonna do the same thing. You're gonna set it up the same way. Okay, so the diagram to the left, B is the midpoint, like we said. B's right smack dab in the middle. And it's the midpoint of AC. Okay? It's in between these two. That's the one that's marked. So it's in the midpoint of AC. This line L that comes through like that is a segment, bisector, of my line AC. I think the one confusing thing about segment bisectors is that most of the time it only goes one way. What I mean by that is that this line that's coming through, line L, is only cutting AC. AC isn't cutting L in half. Okay, so the one that's half, the one that you have to set equal, is the one with the two congruent marks, the two dashes. Okay? So like if they told you that this was 5, this chunk, that doesn't help you find these. Okay? Unless it has the two dashes, that's the only stuff that's equal. Okay. That's a lot of fancy words for stuff that's just equal. So, if I know Q is the midpoint, so Q's in the middle, what do I know about PQ and QR?
They're the same.
They're the same. So guess what we're going to do with 7x minus 16 and 4x plus 2?
And equal each other.
Set them equal. Awesome. So we got 7x minus 16 equal to 4x plus 2. All we got to do is find the value of x. So once we solve for x, we are done. How do I solve for x?
That's
X is first.
Subtract 4.
Subtract 4x, so that gives me 3x. You can totally add 16 first. I don't know. I like to make sure x's are positive. Now I'm going to look at
add 16.
at 16. That gives me 18. How much is x? Yep, I heard it. Whispers. 6. Okay, so midpoint, you're going to set your two chunks equal. Questions on 8? 9 tells me H is the midpoint of GI, so what do I know about GH and HI?
They're the same.
They're the same. What are we going to do with 5x plus 2 and 9x minus 10?
Equal.
Set them equal. How do I solve? Subtract 5x. How much x do I have? 4x. Then what do I do? Add 10 gives me 12. So 4x equals 12. X equals 3 when you divide by 4. That is all good, but I'm looking for GH.
Pardon the interruption. At this time, seniors are now excused to head down to the front steps for the traditional senior class picture. Once again, seniors are now excused to head down to the front
All my
steps
seniors are
for
here.
the senior class picture. Thank you very much.
Okay, finding GH. Here's GH. I found it. How does X help me?
Plug in.
Plug in.
For
So I have 5 times 3 plus 2. How much is GH?
17.
If I plug 3 into here, into my HI, what should I get? I should get 17. These better be the same. Do I? I was lucky. 9 times 3 is 27. 27 minus 10 is 17. So it works. Okay. We got skip 10? Yeah, that's kind of like the other two we did. 11. So skip 10. 11 says G is the midpoint of FH. So what do I know about FG and GH?
It is
So the same.
They're the same. What should I do with 4x plus 3 and 7x minus 12?
Equal.
unequal.
Set them equal. How do I solve?
Subtract 4x.
Subtract 4x gives me 3x. So 3 equals 3x minus 12
Plus 12.
plus 12, which gives me 15. X is how much? 5. That's cool, but it says this whole last part. FH is 6y minus 2, and I need to find y. Well, I got an x. FH, let's look back at our picture. FH is my whole line. So how does finding x to be 5 and having 2 parts help me find my whole line?
Add them.
Add them. What should I do with my x?
Plug it in.
Plug it in. Do I need to plug it into both?
No.
No,
No, because they're both
because they're
equal.
both
Once I find one of them, I can just double it. Awesome. Which one should we plug into?
G.
4x plus 3 I'd like to add to. So 4 times 5 plus 3 gives me.
23.
So that's just FG. If I want to find my whole green one,
46.
I gotta double it to get 46. So my whole line FH is 46. Well, I have this little chunk that tells me FH, which I know is 46, has to be 6y minus 2. So what should I do with 46 and 6y minus 2? Make them equal. They're both FH, so they have to be equal. So 46 equals 6y minus 2. Add my 2 to get 48. 48 divided by 6 is